On December 6, 2025, a NASA spacecraft that had circled Mars for more than 11 straight years simply vanished. One moment, every single system on board was reporting perfectly normal readings, exactly the way it had thousands of times before. The next moment, after a routine pass behind the planet, there was nothing. No signal, no data, no response, just silence pouring in from tens of millions of kilometers away. Engineers at NASA's Deep Space Network waited for the familiar chirp of returning telemetry, the same reassuring blip that had come back on schedule for over a decade, and it simply never arrived. NASA spent the following months quietly trying to bring the spacecraft back before finally admitting the truth this year, that the mission was gone for good and that nobody yet fully understood why. This is the real story of MAVEN, and it deserves far more attention than it has gotten because this was not some minor technical hiccup buried in a quarterly report. This marks the first time in the entire history of American space exploration that NASA has accidentally, physically, lost a fully functioning spacecraft while it was still orbiting another planet. And the not knowing is exactly what makes this story so unsettling. Let's start from the beginning, because understanding what MAVEN actually was makes this loss hit even harder. MAVEN stands for Mars Atmosphere and Volatile Evolution, and it launched in November 2013, arriving at Mars in September 2014. Its original job was supposed to last just one single year. NASA wanted MAVEN to answer one specific, enormous question that had puzzled scientists for decades. Why did Mars, a planet that once had a thick atmosphere and flowing liquid water across its surface, end up as the freezing, dry, nearly airless world we see today? What actually happened to all of that missing air? MAVEN was the very first mission NASA ever sent specifically to investigate this question, and it delivered results almost immediately after arrival. Using its suite of onboard instruments, the spacecraft directly measured how the sun's constant stream of charged particles known as the solar wind was actively stripping away what remained of the thin Martian atmosphere, one tiny piece at a time. Scientists sometimes describe this process as atmospheric sputtering, and while it had been theorized for years, MAVEN gave researchers their first real direct evidence of it actually happening in real time, not just something written into a model. That single discovery alone would have justified the entire mission. But MAVEN kept working and kept discovering for over a decade beyond what anyone originally expected of it. Understanding why Mars lost its atmosphere in the first place matters far beyond simple scientific curiosity, too. Billions of years ago, Mars is believed to have had a much thicker atmosphere and a functioning magnetic field, similar in some ways to Earth's own protective shield. That ancient magnetic field was capable of deflecting the constant outward stream of charged particles flowing from the sun. At some point in the planet's history, that internal magnetic field weakened dramatically, likely as the planet's molten core gradually cooled down over enormous stretches of time. Without that protective magnetic shield in place, the solar wind was free to directly strike the upper atmosphere, gradually knocking gas molecules loose and carrying them off into space, one tiny collision at a time, across hundreds of millions of years. MAVEN gave scientists their first real chance to directly measure this ongoing process happening in the present day, rather than simply theorizing about what must have occurred in the ancient past using only indirect evidence. Instead of the 1 year it was originally built for, MAVEN went on to operate successfully for more than 11 years straight, a lifespan roughly 11 times longer than its planned mission. During that extended run, it discovered multiple different types of Martian auroras, glowing lights in the Martian sky caused by charged particles interacting with the planet's weak, patchy magnetic field. It tracked how massive dust storms sweeping across the Martian surface affected the thin atmosphere high above the planet. It even studied how debris from a passing comet interacted with the top of the Martian atmosphere during a close flyby years earlier, a genuinely rare front-row seat to a kind of natural experiment nobody could have deliberately planned or scheduled. More recently, in the fall of 2025, MAVEN turned its ultraviolet instruments toward 3I/Atlas, only the third confirmed interstellar object ever detected passing through our solar system, capturing images of hydrogen surrounding the comet as it swept near Mars, joining other NASA missions like Psyche and the Mars Reconnaissance Orbiter's high-rise camera in documenting this rare visitor from beyond our solar system. It is a strange twist of timing that one of MAVEN's final contributions to science was helping observe an object that had traveled here from another star system entirely, only weeks before the spacecraft itself would go permanently silent. All told, data from MAVEN ended up contributing to more than 800 separate scientific research papers, an extraordinary output for any single planetary science mission. MAVEN was never simply floating around Mars, quietly taking notes either. It also served a genuinely critical, practical purpose for NASA's entire Mars exploration program. Alongside two older orbiters, Mars Odyssey and the Mars Reconnaissance Orbiter, along with the European Space Agency's ExoMars Trace Gas Orbiter, MAVEN acted as a communications relay. receiving data transmitted from NASA's rovers exploring the Martian surface, Curiosity and Perseverance, and forwarding that information back to Earth through NASA's Deep Space Network. Every single day, MAVEN was quietly helping researchers keep in contact with humanity's active machines exploring the surface of another planet, work that continued right up until the exact moment it vanished behind Mars for the last time. That relay role deserves a moment of extra attention, since it is easy to overlook just how important it actually is. Curiosity and Perseverance, NASA's two active rovers crawling across the Martian surface, are not built with powerful enough antennas to send large amounts of data directly back to Earth on their own. Instead, they typically transmit their images, readings, and other collected data up to an orbiting relay spacecraft passing overhead, which then forwards that information back across the vast distance separating Earth and Mars using far more powerful equipment. Without a working relay orbiter available at the right moment, a rover's collected data can simply sit unsent, waiting for the next available relay opportunity to come around. MAVEN had spent years serving as one of the reliable links in that communication chain, meaning its sudden loss did not simply end its own scientific mission. It also removed one of the available relay points connecting two active surface rovers back to mission control on Earth, forcing NASA to lean more heavily on Mars Odyssey, the Mars Reconnaissance Orbiter, and ESA's Trace Gas Orbiter to keep the rover's data flowing while engineers scrambled to adjust. So what actually happened on December 6, 2025? By all accounts, that day started completely normally. MAVEN had performed the same basic maneuver thousands of times before without a single problem, swinging behind Mars as seen from Earth's point of view, then re-emerging on the other side a short while later, right on schedule. Every system on board was reporting clean, normal readings right up until the spacecraft disappeared behind the planet, exactly as expected. Mission controllers had absolutely no reason to expect anything unusual. This was routine, ordinary spaceflight, the kind of maneuver that had become almost boring in its reliability after more than a decade of repetition. The Deep Space Network itself is worth understanding a little better here, since it is the only reason humanity has any way of knowing what happened to MAVEN at all. This network consists of enormous radio dish antennas positioned at 3 carefully chosen locations spread around the globe, spaced roughly evenly apart, so that as the Earth rotates throughout the day, at least one antenna always has a clear line of sight toward Mars or toward any other spacecraft currently operating deep in the solar system. These antennas are not small pieces of equipment either. Some of the largest dishes in this network stretch well over 200 feet across, engineered specifically to detect radio signals so faint by the time they cross tens of millions of kilometers of empty space that ordinary consumer equipment could never hope to pick them up at all. When mission controllers describe hearing nothing from MAVEN, they mean these extraordinarily sensitive instruments, capable of detecting whispers of signal from the very edge of our solar system, found absolutely nothing where a clear, strong signal should have been present. Then MAVEN re-emerged from behind Mars, and NASA's Deep Space Network picked up absolutely nothing. Silence where a signal should have been. Engineers waited, nothing changed. Hours passed, then days, with no contact ever restored. NASA released a brief public statement on December 9th, confirming the loss of signal and stating simply that mission controllers were investigating the anomaly, promising more information once it became available. That short, careful statement was, for a long time, essentially all the public had to go on. Behind the scenes, engineers were working intensely to figure out exactly what had gone wrong and whether there was any realistic chance of bringing the spacecraft back. To make matters even more frustrating, the timing could hardly have been worse. Mars was approaching solar conjunction, the period when the red planet passes almost directly behind the Sun, as seen from Earth, which occurred on January 9th, 2026. During conjunction, radio communication with anything at Mars becomes extremely unreliable or impossible for weeks at a stretch, since the Sun's interference scrambles the very signals engineers rely on. That meant investigators lost precious time during exactly the window when they most needed clean data, forced to pause much of their diagnostic work until the Sun moved out of the way, and communications with the rest of the Mars fleet stabilized again. In February 2026, NASA formally convened what is known as an Anomaly Review Board, a dedicated team assembled specifically to investigate serious unexplained incidents like this one, tasked with determining both the probable cause of the failure and the likelihood that MAVEN could ever be recovered. This is not a process NASA takes lightly or rushes through quickly. Anomaly review boards typically involve engineers poring over every scrap of available data, running simulations, testing similar hardware here on Earth, and cross-checking every possible theory before reaching any kind of official conclusion. By June, after months of careful investigation, the review board finally delivered its verdict. MAVEN was, in their own words, in an unrecoverable state, and the chances of ever regaining control were described as very unlikely. The mission, one of NASA's most scientifically productive Mars missions in the agency's entire history, was officially declared over. When banks are managing rising concentrations of troubled commercial real estate on their books, credit committees across the industry tend to get more conservative across the board, not just toward real estate borrowers specifically. That can mean slower approvals, higher collateral requirements, and less flexibility than you might have gotten from the same institution 2 or 3 years ago. Understanding your own bank's health and having conversations with your lender before you're in an urgent cash flow situation, rather than after, is simply sound practice in this kind of environment, regardless of what industry you're in. If your retirement account, pension, or investment portfolio includes exposure to REITs, commercial mortgage-backed securities, or regional bank stocks, either directly or through mutual funds and ETFs, it's worth actually looking at what's inside those holdings, rather than assuming diversification alone protects you. Not every fund labeled real estate carries the same office sector exposure, and not every regional bank carries the same concentration risk. The data to check this is publicly available. Quarterly banking profiles from the FDIC, CRE concentration ratios, and CMBS delinquency trackers from firms like TREP and KBRA are all published regularly and are more detailed than most people realize. You don't need to be a real estate analyst to spend 20 minutes looking up whether your specific holdings are concentrated in the riskiest corner of this market or sitting somewhere safer. Now, here are the specific numbers worth actually tracking yourself over the rest of 2026, because this story is going to keep developing in measurable, trackable ways rather than resolving with one dramatic headline. First, watch the office CMBS delinquency rate. Currently sitting above 12% by TREP's measure and even higher by other methodologies, already well beyond anything recorded during the 2008 crisis. If that number keeps climbing through the second half of this year, it tells you the extend and pretend strategy is losing ground faster than lenders can manage. Second, watch the 2027 maturity figure itself. S&P Global's projection of $1,257 trillion coming due that year is currently the largest single-year wall on record. And if that estimate gets revised upward as more data comes in, it's a signal the problem is still growing rather than plateauing. Third, watch bank failure counts and FDIC enforcement actions. One failure in February doesn't confirm a trend, but a pattern of additional smaller and regional bank closures through the back half of this year would validate exactly what Chairman Powell told the Senate Banking Committee directly. And fourth, watch the 10-year Treasury yield alongside the Fed's rate path. Until long-term Treasury yields actually come down meaningfully, further Fed rate cuts alone won't be enough to fix commercial real estate refinancing economics. Because as we covered, this market simply isn't priced off the short-term rate the way people assume. It's also worth being honest about the other side of this story, because a responsible breakdown owes you the full picture, not just the scariest half of it. Distress in real estate has historically created some of the best long-term buying opportunities for investors with patience and available capital. And firms like Brookfield, Blackstone, and PIMCO aren't just retreating from this market. They're actively positioning to acquire distressed assets at steep discounts to where they traded just a few years ago. Industrial real estate and data centers are structurally strong right now, benefiting from logistics demand and the ongoing AI infrastructure build-out. Multifamily housing, despite pockets of oversupply in specific Sunbelt markets, remains fundamentally different from the office sector, because people always need somewhere to live in a way that companies don't always need the same square footage of office space. This is not a story about the entire American economy collapsing. It's a story about a specific, identifiable, and heavily leveraged corner of the economy working through a multi-year reset that started with cheap money in the 2010s and is now colliding with a permanently different world of hybrid work and higher borrowing costs. The $929 billion figure that opened this video was never actually the peak. It was 2024's wave, already resolved one way or another by the time you're watching this. The real story is that every year since has brought a bigger number, not a smaller one, and the true crest, by the most rigorous available estimates, doesn't even arrive until 2027. That's the part that almost never makes it into a single viral headline, because the crisis everyone talked about 2 years ago is actually still building. It doesn't have the same shock value as a brand new disaster. But it's the more accurate story, and it's the one the underlying data from the Mortgage Bankers Association, from S&P Global, from TREP, from KBRA, from the Federal Reserve's own chairman, keeps confirming month after month. So here's what we want to leave you with. If you work in banking, commercial real estate, or small business lending, what are you actually seeing on the ground? Right now, in the middle of 2026, as this next wave of maturities starts hitting. Are credit standards tightening where you are? Is your local bank talking openly about its exposure or staying quiet about it? Drop a comment and let us know, because we read every single one, and this is exactly the kind of ground-level detail that never makes it into the official reports. If this breakdown helped you actually understand what's happening underneath the headlines, instead of just reacting to a scary number, subscribe and turn on notifications, because we're going to keep tracking the delinquency data, the bank failure list, and the maturity schedule every single month as 2026 plays out. Thanks for watching, and we'll see you in the next one.